Just because you cannot hear that audio has been edited, you can still see it with your eyes. And today, that's what we're going to be talking about. You see, I'm going to share an intriguing criminal case I recently worked on and gave expert testimony for because it highlights the power of spectrogram analysis in audio forensics. You see, this is one of the methods used by digital forensics experts to spot signs of tampering and manipulation. Well, in this case, I was retained by the criminal defense attorney whose client was charged with 4 charges of assault. And the primary source of evidence used by the prosecution to substantiate these claims was an audio recording between the defendant and his girlfriend. Well, the defendant claimed that the audio recording had been edited, and his attorney contacted me to analyze it. And when I listened to the recording with my ears alone, some of the transitions sounded off, meaning the context changes in the conversation seemed incongruous. They didn't fit together, but sometimes conversations are like that, right? They don't always all flow perfectly. Sometimes they're choppy and the rest. But there were no other anomalies that I could pick up by listening alone that would give me sufficient reason to doubt that authenticity of the recording. And if I could not hear them using studio-grade equipment, then there's no way the judge and attorneys heard anything in the courtroom quality speakers on the defendant's first court date, which occurred before I was brought onto the case. Well, in my analysis, the first thing I noticed was that the audio file was in MP3 file format. On an iPhone, audio files are recorded in M4A format. So this means that the audio was changed in some way, even if it was just a simple conversion of the audio file from M4A to MP3. While that doesn't mean that the audio was manipulated to change the context or contents of the actual words said back and forth, it was the first red flag, so to speak. Well, first, let's jump ahead in time to the trial, and then I'll come back to explain my analysis in detail. The alleged victim testified on the stand that the audio recording was created using her iPhone, which she had set to record and hidden in her pocket. She stated that she transferred the recordings to a computer and then burned it to a CD, which she then provided to law enforcement. Well, when asked in cross-examination, she stated emphatically that she in no way edited or changed the original audio file. Now, let's back up in time to my analysis. So even if you cannot hear manipulation with your ears, you can see audio manipulation with your eyes. You can see evidence of tampering through a spectrogram analysis. I loaded the audio recording into an audio analysis software and examined the spectrogram, and I was able to pinpoint 80 different points where the audio had been manipulated. Well, let's dive into the details and see how spectrogram analysis played a crucial role in uncovering these edits. So first, what is a spectrogram? Well, a spectrogram is a visual representation of the spectrum of frequencies in a signal as they vary over time. So in other words, a spectrogram is a visual representation of auditory data. You are seeing what you would hear. It displays frequency on the vertical axis, time on the horizontal axis, and the intensity of the frequency is shown using color or brightness. You see, this tool is incredibly useful in audio forensics for identifying anomalies that are not easily detectable by ear alone. A good way to understand a spectrogram is to compare it to a musical score. I want you to imagine that you're looking at a sheet of music. Each note on the sheet represents a specific pitch played at a specific time. Now, let's break this down and how it relates to a spectrogram. The time axis, that's the horizontal lines on a musical score, represent the progression of time. The horizontal axis on a spectrogram shows how the sound evolves over time, and each moment as time is captured just like each beat in a piece of music. The frequency axis, or the y-axis on a musical score, that vertical position of a note indicates its pitch, with higher notes placed higher on the staff. Similarly, the vertical axis on a spectrogram represents different frequencies, with lower frequencies at the bottom and higher frequencies at the top. Well, we have a third dimension when we're talking about a spectrogram analysis, and that is the same as in music, where you have dynamics or loudness of a note, where it's indicated by symbols like a P for piano or soft, or F for forte or loud. In a spectrogram, that intensity or loudness of a frequency at a given time is shown by the color or brightness. See, the brighter colors or more intense shades indicate louder sounds. All right, so just one quick analogy, and then we're going to get to the actual examination. So let's imagine that we're analyzing a bird song, right? A song of a bird. The time axis, that left to right progression, shows the sequence of the bird song, just like reading music from left to right. So the bird is chirping, and over time, you see those chirps go across. The frequency axis, the bottom to top range, shows the different pitches of the bird calls, right? The higher the pitch, the higher it will be. The lower the pitch, the lower it will be, just like notes on a musical staff. Then the color intensity, how bright or how strong those color indicate how loud each chirp is, just like those musical dynamics we talked about earlier. So now onto the examination. So I'm going to show you the actual file in a minute so you can see this for yourself. But once the audio file was loaded, I began a visual inspection of the spectrogram, okay? The key indicators of edits in the spectrogram were hard cuts and empty sound floors. See, these are areas where the audio waveform abruptly changes, indicating that a section has been removed and the remaining parts have been spliced back together. In the spectrogram, the edits were clearly visible as sharp vertical lines where the frequency content suddenly stopped and then started again. You can think of these as like digital tool marks, and these hard cuts are a telltale sign of splicing. See, additionally, in this particular case, the sound floor was absolutely empty at these points, meaning there was no background noise or ambient noise, which is extremely unusual in a continuous recording. You see, I meticulously went through the entire audio file, marking each point where these hard cuts and empty sound floors appeared, in total identifying 80 different spots where it occurred, okay? And the level of detail is crucial in forensic analysis that we're looking at here with like a spectrogram analysis, as it provides concrete evidence of tampering. See, without this analysis, the recording would have passed as the real thing. All right, so let's take a look at the actual spectrogram analysis that I performed. So as you watch this video, this was a demonstration I had ready for trial, the video I made, where you're going to see the spectrogram going across in time, and then every spot where there was an edit, I have a red arrow pointing up to that section, okay? So let's take a look at that. I'm going to play it in fast speed, so keep your eyes glued to the screen so you can spot all the edits, and then I'm going to tell you what happened at trial. So I gave expert testimony in this case explaining what we've already covered, right? The splicing and the cutting, the spectrogram analysis, and the rest. And as a part of my report, I created the video that you're watching right now showing all 80 points where the audio had been cut and spliced together and edited. Yeah, the video was necessary to translate a complex technical concept, the visual representation of auditory data, to the court. See, often words alone are not enough to explain technical concepts. And without this video, the impact of my expert testimony would have been severely diminished in my estimation. And on cross-examination, the prosecution asked me how this could have occurred in the normal course of creating an audio file and even posed a few scenarios. And most of the scenarios were impossible, and only one was possible but extremely improbable. After my testimony, the court excused me, and the next day, the defense attorney let me know that the defendant was found not guilty on all 4 counts of assault. See, that spectrogram analysis proved to be an invaluable tool in this case, allowing me to identify and document the edits with precision. And this method not only helped in detecting tampering, but also provided a visual representation to present this evidence in a legal proceeding. And if you're interested in learning more about spectrogram analysis or have any questions about audio forensics, feel free to leave a comment below. Don't forget to like, share, and subscribe for more insights into the fascinating world of digital forensics. And remember, digital evidence is everywhere. Thanks for watching. I'll see you on the next video and live stream.